Greetings, everyone. Today we're going to continue to explore the basics of inequalities and talk about the solutions of inequalities. You do have a note sheet for this, so make sure you have that ready to fill in and as always, pause when needed. Let's jump right into the examples. We don't need any notes for this because this was our Unit 1 notes. We're going to take this sentence and we're going to write it as symbols. X is less than or equal to 8. X is less than or equal to 8. So we have to be confident going to symbols and going to words. Example 2. This one's confusing. 5 less than y is greater than 10. Whoa, whoa, whoa. It sounds like we have two inequality words there, but one of them is an operation. So here's what you need to keep an eye out for. This says is. Is greater than means that's the inequality symbol. So let's start with that since we have is. Is greater than. To the right, I'm going to have the 10. But on the left, 5 less than y. This less than means subtraction since there's no is in front of it. So we're going to have 5 less than y. Now this order needs to be exactly as I have it written. Let's do the reverse. Let's take symbols and write it as words. So I'm going to say a number b, remember that phrase a number, we put it in front of our variables, is, and then we read the symbol, is greater than, make sure you use THAN, 9. Let's try another one. Now this one, I'm not a fan that the letter isn't first. So I'm actually going to flip-flop this. That's a very, technical math term. Just kidding. Let's write an H and a 16. So if I flip those, I also have to flip the symbol. See how I did that? If you flip one, you flip all. So now if I write it in words, a number H is, you need that word is, greater than or equal to, don't forget that piece, 16. Make sure at any time if you need to pause, rewind, make sure to take care of that. The next thing we're going to review in this specific lesson is checking to see if a number is a solution. So here we're given this inequality statement. It has multiplication, it has addition, and we're given 3 numbers that we want to test. Think of those as test numbers. So I'm going to start with my first number. Now we need space for 3 sets of work. Let's start with the 2. What that means is I'm going to rewrite the statement, but wherever there's a letter, I'm going to change it to the number. See how I changed the y to a 2? Now when they're next to each other, that implies multiplication. So please put a dot there. Otherwise it looks like 32. Now I have a statement and I need to decide if it's true or false. Well, I got a little bit of calculating to do. PEMDAS, what's 3 times 2? 6. What's 6 plus 5? 11. See how I just simplified that down? And now my goal is sort of a true-false scenario. Is 11 less than 20? Yes, that's good. So here's what you can do. You can say true. You could give me a check mark. You could circle the 2, right? I'm open to how you identify that 2 is good. Let's repeat the process, but this time with 0. We're going to rewrite the statement, but wherever there's a letter, I'm going to put a 0. See how I replace that? Let's calculate. 3 times 0 is 0. Order matters. 0 plus 5 is 5. Is 5 less than 20? It is. So that's good. So check mark or circle or say true. You don't have to do all of those, but tell me you understand. Again, quick review. We're simplifying. So when we simplify the left side, we multiply or divide first and then add or subtract. Let's take care of 5. Repeat the process. 3 times 5 plus 5 is less than 20. Instead of a y, I put a 5. 3 times 5 is 15. 15 plus 5 is 20. Is 20 less than 20? No. So first of all, you can write the word false. You can put a slash through the symbol like nope, not true, or you can put an X through the number. But I need some notification that you understand that is not true. Let's try this again. I need to see work. Now you will have practice. You will see this on assessments. If you're given 3 numbers, I need 3 sets of work. Let's start with -1. Instead of x, I'm replacing it with a -1. I need to see this work. Do not give me just an answer or just a true. I need to see the calculations broken down. 2 times -1 is -2. -2 minus 4 is -6. Is -6 greater than 10? No. No negative number is bigger. That's a no-go. Let's try 8. 2 times 8 minus 4 greater than 10. I replaced the x with an 8. 2 times 8 is 16. 16 minus 4 is 12. Is 12 greater than 10? Yes, that's true. That's good. 8 is good. You can probably make an assumption about 10, right? And I'm okay with you thinking it, but I still need to see some work. Let's do less work though. Like I want to see what I have written here in blue. I replace the x with a 10. But let's do mental math. 2 times 10 is 20. 20 minus 4 is 16. See how I just skipped one little step? Is 16 greater than 10? Yes, that's good. That's true. 10 is good to go. Let's take a look at this last example. This time our goal is we are going to find 3 numbers that would make this true. I need to check 3 numbers. Now, I need a number that when I take away 2, I'm still bigger than 3, right? So my first thought is let's pick a huge number. Let's say 100. 100 minus 2 is 98. Yeah, that's definitely greater than 3. Let's pick something not so ridiculous, like 8. 8 minus 2 is 6. Is 6 bigger than 3? Yeah. And you know what? Let's try as close as we can get. What could I subtract 2 and just be bigger than 3? 6. 6 minus 2 is 4. Is 4 greater than 3? Yeah. So here's the numbers that are not okay. You don't have to write these down, but let's talk about it. 5. 5 would be not good because 5 minus 2 is 3, and 3 is not greater than 3. 0. 0 would not be good because 0 minus 2 is -2, and -2 is not greater than 3, right? So we hit this number where anything on the other side of it's bad. So we need numbers that are 6 or bigger. So we could even say 7, we could say 10, we could say 500. Any of those numbers would work. Now this was a short lesson, so make sure to check Google Classroom, see if we have a task or see if you have another lesson to catch up on. Let me know what questions you have, and until next time, have a good one.